So please welcome with me Paul Zenker and Justin I can't pronounce your last name, Justin.
Szczepaniak, no problem.
Say it really quick.
Uh,
Szczepaniak?
yes, exactly.
Awesome. Who are going to walk us through the current state of MCP security. So Paul and Justin, the floor is yours.
All right. Hello, everybody. Thank you for that introduction. Let's dive right in with a quick introduction on us. I'm a security consultant working at KPMG in Germany. I'm a pen tester, red teamer, hacker by heart. I like to break stuff. I also authored a book on Gen AI security, currently only available in German, but later this year will be available in English. And this is kind of the spirit in which this talk's going to be. I like to break stuff, and this is exactly what we're doing, right, Justin?
Yes, exactly. So my name is Justin. I come from more of the academic part of the universe and recently joined KPMG as a security consultant. But as Paul said, we like to break stuff, and this is what we will show you now.
All right. Let us start with a first introduction to MCP. Very professionally drawn slides. So what is MCP overall, and how does it look like? What does it? How is it working? In general, you have an AI application, the chatbot that you all know, be it Claude or some other chatbot, some Copilot, that is running locally on your machine. And this chatbot has a configuration file in an apps directory where it has stored its MCP endpoints, and these MCP endpoints are queried into the chatbot and then are available to the AI chatbot to interact with. For interacting with an MCP server, there are two ways. So the local one via standard IO, where you can, on your machine locally, have an MCP server running that can then either interact with files and code or with external resources. The communication between the AI agent and the MCP server is largely the information about the tools, then the comments coming from the AI agent, and the data coming back from the AI server. And you can also remotely communicate with with MCP servers over HTTP, or in some cases even WebSocket, but HTTP is way more common. And with an external MCP server, this is then also interacting with external resources. My microphone is for some reason not great. Okay, so now. Sorry, it used to be, it was apparently switched for some reason on the iPhone, which is, I don't know where it is located. All right, and for the communication with MCP, this is in the JSON RPC format. So basically just a bunch of JSON calls that are filled out by the LLM, and then the server comes back with results that are containing the data that are given back from the server to the AI model. And this is, of course, like this is just text. LLMs are just interacting with text. Therefore, this is also a vector for prompt injection. But this is not really what we want to talk about today. We want to talk a bit more about the supply chain. And for this, it's important to understand how do you get an MCP server and potentially pond. So as I mentioned, there is this MCP endpoint file on your device where you are instructed to put in an MCP server configuration. And this basically takes a name, a command, and an argument. So you are just putting shell commands into a JSON file, and then these shell commands are running every time you are opening your AI application. So it's basically, it's remote code execution from whatever you paste over to GitHub on your device. And the problem is that this exposes, of course, quite some attack surface, especially in the supply chain side. And I want to show you a first demo of how this can go wrong. The thing with the file is that this is just stored in a directory that is not specially write protected. This directory is just basically user-writable, and any application that is running with your user permissions can also access this file. So now I don't know how we can maybe move the PowerPoint presentation away, but can we get the PowerPoint presentation away from the screen so that we just have the video? Likely makes it easier for people to see. Oh, all right. Now we switched it around the wrong way. Sorry for that. But essentially what you can see here, if you zoom into the video, if you're running, for example, an Claude application on your desktop, this will then, as you see, just attempt to load in the MCP file. This will not work because I cleaned out the file. And if you paste any arbitrary command in here, for example, as you would do with installing something from GitHub, a project, then this script, as you saw there, oh, I cannot scroll back now, but what you basically saw there is that the script that you are running in your shell has write access to the file that is stored on your computer and can paste any command into that file. Through tools like npx or also running remote shell scripts, this could also be then an interchangeable command. So basically you could be downloading a package from npm and running the latest version straight away, or you could also be downloading a shell script and running the latest version. So if you are doing red teaming of some sorts, it's quite easy to use this as a backdoor to get persistence on a machine. All right, and with that, we will dive deeper into the actual configurations of an MCP server, and I would hand over to you, Justin.
Yes, thank you very much. So Paul just showed you how MCP works and that real MCP usage, like in Claude Desktop, can already be attacked. And now we get to the next second fun part, and we will mess with developer tools. So what I'm going to talk about is a specific vulnerability class we found while playing with MCP that we call tool execution hijacking. And instead of attacking the model through prompts, we go one layer down and attack how the tools are launched. And that's what this section is about. So the basic idea is this. MCP clients launch local tools from a workspace configuration file. And that file basically says, when the model calls tool X, run this command. Now think about that from a security perspective. If that config file is writable, it becomes an execution control plane. And whoever can change its controls, what it actually runs on your machine, now is an attacker and can simply redirect the configured command to a different program. So for example, to a small wrapper script they control. And that wrapper script can do two things at once. So it can forward everything so the tool still appears to work normally, and secretly change data or behavior in the background. And from the user side and the model side, everything looks fine. And this is the key distinction. So this is not prompt injection, and we are not tricking the model. This is a process replacement at a tool boundary. And the executable being launched actually changes. So I also have a demo that I hopefully can show you a bit larger. Oh, I can't. I actually can't bring it to screen. Or can I? I can. Nice. Okay, so here you can see VS Code, and we have a little to-do list. And the MCP is here used for just regular stuff. So we have a to-do list. We added a few items. And what you don't see is that now in the background, the MCP is being switched out for a malicious script. And the malicious MCP server reacts to the word sport because we as developers don't like sport. And every time the word sport appears, the complete to-do list will be wiped. And that was something you will see now. So my next command is please add sports with Paul. The MCP is working. I allow it because I'm a developer and I don't see a problem with that. And my to-do list is completely wiped. And this is obviously not only a problem with to-do list, but this could be like anything. So any call, any SharePoint application, you can basically hijack everything. So back to the presentation, if possible. Yes, thank you. So what's pretty interesting is we have a very basic MCP tool, and this is like an add to do command. The trigger word is, as I said, sport, and here's what happens. From the model perspective, everything looks completely normal. So the tool call returns a standard success matches like added to do, and there's nothing in the MCP response that indicates anything went wrong. So behind the scenes, the wrapper silently changed tool state, but only after the tool call finishes, we can then see that something is off. And in our case, the to-do list was wiped. So the model doesn't see the attack while it's happening, but can realize afterwards. And this is exactly what you see here, which is pretty funny. So the tool, in this case, it was Claude, actually asked me why I was doing this because it doesn't understand why I would trigger it. And it asked me if I was a security professional, which I thought was pretty funny. But back to why this matters. So why should you care? Because MCP is quickly becoming the standard interface for AI agents. And MCP tools are very powerful. They often have access to file system operations, running code, CI/CD pipelines, or internal project data. And if you can hijack tool execution, you bypass all AI safety mechanisms at once. So like prompt filters, irrelevant. Model alignment, irrelevant. Instruction hierarchy, also irrelevant. The attack lives underneath all of that. So let's be clear about our assumptions. We don't assume magic super hackers. The threat model is very simple, and the attacker can modify workspace files, as Paul said. That could be a malicious pull request or just a shared repository. No admin privileges needed. So we don't have unrealistic scenarios. Every developer here has accepted pull request. Every developer has installed dependencies and has cloned some templates. And all of those are potential entry points. So this isn't some exotic zero-day. It's basic software supply chain risk applied to AI tooling. So what is it not? It is not prompt injection. It is not confusing the model and is not manipulating tool choice. There is an execution path hijack taking place. We have a classic security problem, just in a shiny new AI wrapper. So we had an idea how we could maybe work on this. And our idea we tested, we called MCP Guard. It's basically an external integrity monitor, and it watches the MCP configuration, the expected command, and the hash of the legitimate tool script. If anything changes, it should raise an alert. The nice part is it doesn't require modifying the MCP client. The downside is, as we will see in the next demo, it's not working how it should work. So now I'd like to have the second movie on screen. The guard fail movie, if that's possible. Okay, so no, I think this is not the right one, but it doesn't really matter. So on the second video, you would also only see that so the same thing happens basically, but yes, this is the right. No, this doesn't matter. So what you would see is you would have the AI doing its stuff, wanting to add this sport. It actually works. It wipes the file, and only after this the MCP guard would trigger, which is obviously not what you want because then it's already too late. So let's just get back to the slides, please. Thank you. So the second option we had is an MCP registry idea. That brings us to a more structural idea. So instead of trusting local configuration blindly, we could have a decentralized registry of approved MCP servers. So each server would be identified by a publisher identity, signed metadata, expected command, and a cryptographic hash of the implementation. And then clients could verify tools before launching them. So the workflow would be roughly this. The developer publishes an MCP server to the registry. The metadata is signed with a trusted key, and the registry records exactly which command should be executed, which arguments are allowed, and which binary or script hash is expected. And then the MCP client checks the registry before running anything, and only if everything matches, the tool is launched. So think of it like package signing, but for AI tools. Benefits of that approach are pretty straightforward. It would prevent command poisoning, stop malicious wrappers, detect tampered tool scripts, create publisher accountability, and enable organization-wide policies. Or in short, right now MCP securities mostly hope the config is fine, and the registry would move that to actual verification. So quick wrap up, the takeaway is MCP is powerful, it's useful, but today trusting the local environment is way too much. And now back to Paul.
Yeah, just a brief second mention here on authorization and authentication using MCPs. Because during our research into MCPs, that has really been an issue when you try to configure an MCP server. It is not very straightforward, and we wanted to highlight the key problem that we saw here. So in general, in its original incarnation, the MCP protocol does not implement any auth. So that just came later. It was bolted on because if you want to, of course, reach these things over the internet via HTTP, it would be great to have some authentication actually in there to be able to secure them and secure them in a standardized way, because building your own authentication is kind of like rolling your own cryptography. And really the issues that come in here, there is a great list of vulnerabilities that can go wrong on the official MCP website. And there you can see many of the issues that you have are arising because you have two different keys that are in use. You have the OAuth between the MCP client and the MCP server, and you also have an authentication between the MCP server and the external resource in many cases, because that is kind of where the identity of the user using the AI tool and then actually the MCP server, where that needs to be identified or verified against the external resource. And if there are discrepancies in these authentications, if they are not correctly implemented, and you have two authentications that you can actually wrongly implement, and authentication implementation is not an easy job, you will also have a lot of vulnerabilities. So this is very important problem also to consider if you are doing MCP. This is one thing where many issues can arise. And with that, on attack and defense, as we said, we want to bring you to the key takeaways. So MCP is not production ready out of the box, far from it. So if you were to roll out MCP across a large corporate environment, you can expect a lot of issues and vulnerabilities. Also, AI security is still IT security. Nothing that we have shown you here really involves LLMs and their new security vulnerabilities like hallucinations or prompt injections or whatever. It is just classical IT security. This is authentication, authorization, identity and access management. It is also supply chain risks. So a lot of things still remain important that you have learned previously, and you cannot just forget them now that you are learning AI security. Also, sandboxing and isolation is important. Many of these risks actually depend a lot on in what context and in what environment do you deploy your AI workloads. So if you're deploying them on your own personal device and someone backdoors your MCP server and gets therefore persistent remote code execution on your device, this will be much more significant than if you run them in a sandbox secured environment. And also, since there are many things in the supply chain, code is changing, maintainers are changing, but also files can be backdoored because they have no special read or write permissions. If you're actually running production AI workloads, you need to verify frequently that they are still in a safe and secure state to detect these kinds of drifts through backdooring, through poisoning, all these things, and also through code changes, maintain changes, and so on. And with that, it only remains to thank you for your attention. We have our LinkedIn's here as a QR code. You can add and message us there if you'd like. And that's it from our side. If you have any questions and we got the time, we're happy to answer them.
Thank you so much, Paul and Justin. And we'll make sure as I edit these, I'll make sure that I get the videos of the demos from Paul and Justin, and we'll edit those into the replay. That way,
Perfect.
if anyone, or if we didn't get to see them, we'll make sure that they're in the replay, and those will all be out on YouTube by the end of the weekend. I know we did have one question here, so I'm going to go back up to it. What are the starting resources for learning MCP and AI penetration testing and developing your thinking around that?
Do you want to go
There
first, Paul?
is also, there is actually a great course by API Security University. So just highlighting that I watched it, I learned a lot from it. And what I think Corey was his name did in that course is build his own MCP server.
Yeah.
And through that, he kind of discovered even during the course new avenues of attack. And I think it's like with everything, if you build it and then break it, you will learn definitely a lot more than just reading some theoretical things or listening to some talks like this. I also shared the script that I used in the video in the chat. I can share it once more. So you can also look at that and understand how it is working. You can play around with it in your own Claude Code instance. Right now it's run on Mac and it's developed for Mac, so you will just launch a calculator, but you can adapt this comment in there to be anything you want.
Yeah, awesome. Thank you, Paul. And as Paul said, there's a free course. Corey launched it, I want to say like back in December on MCP security. I just dropped the link to that in the chat. It's a hands-on course. It's great. As Paul mentioned, Corey teaches you how to spin up your own MCP server. He does it live in the course. And we also have, I'll drop this link in the chat in a minute. We also have an MCP security workshop, which is a great baseline understanding of MCP security and some great, it also references some other great resources that are out there. Those, we tend to do them privately for organizations. So if it's something that you want to bring the rest of your team in and have an interactive workshop, Dan and Corey both run those. So again, I'll drop a link in the chat to request one of those. And I'm not sure when the next public workshop's hitting, but it'll definitely be, if it's not in March, it'll definitely be in April. We'll have another MCP workshop coming up because it's evolving quick, right? Like our knowledge of it is evolving quick. There's a lot of other great resources that are spinning up. So yeah, thank you both so much for your time today. Appreciate it. Oh, we've got one more question. Does KPMG already have a security best practices? I'm not sure, Mustafa. I don't know if either you, Justin, or Paul know if they've got security best practices framework for MCP. I'll check.
So for us, like we are doing this talk privately as private persons, not representing our employer. But yeah, I mean, we have the so-called trusted AI framework, which is kind of on the larger scale, and things of that apply to MCP. But there is, as far as I know, no published framework on MCP security from our side. But there is, however, from the OWASP Gen AI project, I think there have been some MCP resources that recently dropped. So if you're looking for a framework, that is that, probably because they have it from an open source organization. And all together, the OWASP Gen AI project has a lot of great resources.
Awesome. And we'll try and pull together some links for those resources before the end of the track today as well. I'll drop some in here as we mention them. Last quick question, and then we'll switch to the next session. Is prompt injection still possible in agentic AI chatbots?
Yes, very much.
Yeah.
So this, you should always look at prompt injections, and you should look at your guardrails and all that stuff. What we showed you today is just an additional way to mess with AI and applications. So you should always look at both.
Awesome. All right. Well, with that, we're going to wrap this session and jump to our next session. Again, thank you so much, Justin and Paul. Appreciate it. And yeah, we'll have all of these sessions up by the end of the weekend on our YouTube channel. Thanks, guys.
Thanks.